All right, so 10.3, our other section. Hypothesis test for matched paired samples. Do students perform worse when they take an exam alone than when they take an exam in a classroom setting? Do they do worse alone? I don't know, it's kind of a weird question. I don't know if it make any difference. So, exam alone, so do they do worse when they do the exam alone than when they take it in a classroom setting? So we're still comparing two groups. 8 students were given 2 tests of equal difficulty. They took one test in a solitary room, and they took the other in a room filled with other students. The results are shown below. So in other words, this is the first student right here. And alone, he or she got a 79. In the classroom, he or she got an 84. And then this is the second student. Alone, he or she got 89. In the classroom, did better, got 94. Here's the third student. Alone, 79. Classroom did a little worse, 74. Fourth student did same both places. Fifth student did a little bit better in the classroom. Next one, a little better in the classroom. Next one, a little better in the classroom. Last one, a little better in the classroom. Notice this data is matched up. In other words, we're not going to do it like we just did it in the last section. In other words, I'm going to do something different. Why am I going to do something different? It's because the data is matched pairs, meaning these two numbers are definitely connected. It's not like we just grabbed 8. We could have. Another way you could have done this experiment is you could have grabbed 8 students at random, gave them a test in class, and then 8 students at random gave them a test alone. But they didn't do that. They had the very same student take a test alone and then in a classroom. So those two numbers are connected, aren't they? There's a relationship there. They're matched up. That's the same person, right? So this is what we call matched pair data, meaning there's a significance to those numbers. Those numbers relate to each other. They're the same person before and after. Or not before and after, alone or in the classroom. Is that making sense? See how, so you need to recognize this on the next exam when you read this kind of question, that it's a different kind of question because the data is matched in nice equal pairs right on through. The numbers are related to each other. Like if this is a strong student, for example, then he or she is probably going to do better on both alone and in the classroom, than some of the other people, for example. Or if this is a weaker student, then they're going to do worse on both. But it's one person, and so they're matched up. This is matched pair data. Okay, so what do we do then for matched pair data? How do we do? So I've given you the game plan so far. 10.1, again, let me remind you, that was 2 proportions, and we used what? We used a 2-prop z-test. That's how we do that, 2-prop z-test. And then we just finished 10.2, and that was 2 independent samples, and we used the 2-sample t-test, right? Well, now everything's going to change. In 10.3, we're going to have matched pairs. They're always going to be connected in pairs. And so what do you do in that case? You're going to do something special. L1 and L2. You're going to put your data in L1 and L2 like usual, right over here. This data is going to go in L1. This data is going to go in L2. But then here's the special thing. You tracking with me? You're going to go, so then you've got to go like this. You've got to go L1 minus L2 stored into L3. Now, how do you get L1 on your main screen? 2nd and 1. How do you get L2? 2nd and 2. Store is a button somewhere. Yeah, the store button is just located lower left corner right above the on button. You don't have to hit 2nd or anything. Just hit that STO button right above on in the lower left corner. And then you know how to get L3. 2nd and 3. So after, this is after you put the data in L1 and L2. So first put the data in L1. First put all this data in L1. Then put all this data in L2. And then after that, then do this. Because what that'll do is that'll store the differences into L3.
Should we move over to L3 and then do it?
No, you can just do it from the main screen. Just go from the main. So probably what you should do, and I'll give you all this when I give you that handout. But let me tell you specifically what to do. I should write out some steps. So let's do this. So 10.3 matched pairs. Let me back up and be real clear. So step 1, L1 data into L1 and L2. So put the data in L1 and L2, and then hit second and quit. In other words, quit. The quit button is right above the mode key, right at the top. Because you want to quit out of that L1, L2 stuff. And then you do L1 minus L2 stored into L3. That's your third step. And the way you get L1 is second 1. The way you get L2 is second 2. The way you get L3 is second 3. So put the data in L1, put the data in L2, and then quit, second quit. That's right at the top of your screen. It's above the mode key, the very top. Hit second quit out of that. Then you'll be on the main operating screen and go L1 minus L2 stored into L3. Oh. What's that? No commas. No commas, just L1 minus L2 stored into L3. So what we're doing, let me give you a feel. I don't want this to be totally blind for you. What you're doing is you're really looking at the differences. You're saying, because this is the L1 list, right? And this is the L2 list. So you're basically taking L179 minus 84, which is negative 5. And 88 minus minus 94, which is negative 6. This is what's going to go in L3, these differences. These are the differences. L1, the next one will be positive 5, and then 0, and then negative 3, negative 1, negative 4, and negative 3. Does that make sense right there? Why would that matter? Well, that's telling us the difference whether they did better before alone or classroom, huh? Does that make sense? It's really the differences that tell us the difference between taking the test alone versus taking the test in the classroom. See how if the numbers come out negative, that means the bottom number was higher, which means they did better in the classroom. If most of them come out negative, which they are. See what I'm saying? So that's what the calculator is going to use to tell us whether they're doing better in the classroom or better alone, is the positives and the negatives on all those difference numbers. See how the subtractions is what we really need on that. So anyway, the calculator's got, you can look in L3 if you want. It's got it, that whole list L3. It just populated it with L1 minus L2. It just put, the calculator at that moment just put all of this into L3 when you typed that. It just stuck all those differences in L3 is what it did. You don't need to look. You can if you want to. But my point is, L3 now holds everything important to us, those differences. Everything's going to be done upon L3 now. L3 holds the differences. Okay, so let's go to the normal stuff where we, I'm skipping again the claim, the HO, and the H1. So the claim, what is being claimed here? Do the students do worse alone? Worse alone. So that's mu1 is less than mu2, huh? Mu1 is less than mu2. What I wrote right here is true. Mu1 less, right? Worse on the alone, right? The alone is lower, we're saying. But think what that means for a second. If I take that, so you guys tracking with me? This is the part that's going to be a little more mathematical. Might be confusing for you. You good so far, right? You agree mu1's less than mu2. That's what we're saying. Worse on the alone, so that number's lower, less. Okay, if you take, they want to put those together, so they want to mathematically manipulate it, and so what they're going to do is I'm going to subtract mu2 from both sides, making that 0, and this is now mu1 minus mu2. Do you see how that's the same mathematical statement? Does that seem bizarre? Right? So that's true. It might be easy, if you didn't like that, that's okay. I can say it a different way. How about this? Mu sub d, the difference. What are we wanting these differences to come out to be if we're saying the alone is worse? Or no. The alone is worse. Do they do worse alone? If this is worse, if the alone is worse, then the number's lower. And when you subtract, you'll get something negative, won't you? So that means less than 0. Negative is less than 0. That's what we're claiming. The difference is less than 0. Does that make sense? Is that better that way? I showed it, if you care about that other way. I originally said mu1 less than mu2, and then I subtracted mu2 from both sides, and I got mu1 minus mu2 less than 0. That's the same thing as saying the difference is less than 0. I don't know if you don't like that as much. So is this making sense so far? Is this statement okay? That's a lot of the trouble students have, is reading these words and coming up with this. Do you see why that's the case? Because again, if they perform worse alone, then the alone numbers are lower. When you subtract the higher classroom numbers, you get negative answers. So we're saying the difference is less than 0, negative. So you get better with that? Okay, good. The rest, then we just go HO, H1. What is HO always? Equal. But we use mu sub d. So instead of mu1 and mu2, what is mu d? It's these differences. We're all focused on those differences. In a matched pairs, we already matched them up and did the subtraction and threw it in our L3 data list for the calculator. It's all about that list of differences to tell us the story on alone or classroom, which one's worse. So the mu d equals 0. This, will be mu d less than 0. Weak evidence, strong evidence, like usual. All the rest is the same. We'll go through it. But is that good so far? Do you see that? So we use mu sub d, the differences, on a matched pair problem. The average differences. Mu is average, right? Mu d, average differences. So we're saying, are these differences usually negative? Looks like they are, huh? If so, that means the alone is less. But is there strong evidence, or was it maybe just luck? That's what we're always answering. Okay, let's go to the next screen. So this is going to be mu d equals 0. This is going to be mu d less than 0. Weak evidence. Strong evidence. All right. So, I didn't tell you how to go to your calculator, did I?
No.
All right. So let's go. So on 10.3, let's go back to the steps. So on step 4, then, you know where we're going to go? Just normal t-test, not to sample. That's which confuses people a lot. Why? Why aren't we doing to sample? Because we're only focused on the one group of numbers now, the L3. We don't care about L1. But that's the trick now. When you go to t-test and it asks you what list are you going to tell it? Where are you going to tell it to go grab the numbers? L3, exactly. The rest is normal. But do t-test and tell it to go to L3. You're choosing a data, right? We're always going to choose data because this is coming from a data list, the list of data that's in L3. So I'll go over here. So we're going to 10.3. We're going to do t-test, choose data, and the list is L3. So not L1, but L3. Remember how you get L3? You hit second and 3.
Do we put the mu as 0?
Oh, yeah, that's 0. Yeah. Yeah, back over here. The H0, yeah, let me write that again. Correct. Yeah, the mu sub 0 Yeah, I should have done that first, huh? The mu sub 0 is 0. Remember, that always comes from the H0.
Okay, that means my number's a lot more small.
We good? Remember, the mu 0 always comes from the H0. That's 0. The list, again, is L3. And that comes from second and 3. Frequency's 1, always. And what's ours is a less than test. So choose less than. And calculate. And you get your numbers. I'm getting a T value, negative 1.726, and a P value, 0.06398, so that would round to 40, huh? 0640, you getting that? So now we got to compare that P value to the significance level. I don't know what the significance level was. Where did it say the significance level? Oh, 0.05. There it is. 0.05. So this P is greater, isn't it? So the P is not low. The HO does not go away. So we keep the HO with its weak evidence. We get rid of the H1. So that's weak evidence. So that's not significant, but insignificant. It's one of those insignificant ones. And this one says insufficient evidence. That's it. Insufficient, not significant evidence. No. And there we go. So what does that mean? Do we believe that people did worse alone? Did the evidence support that they did worse alone? No, the evidence was too weak. It was just too weak. So there wasn't really a strong difference. There was a 6% chance of luck. Too much chance of luck. Could have happened by luck. So are we good there? Is that making sense? I'm going to try another one of these, I'm assuming. These are a little tricky, aren't they? You good on that? They're the same every time. I don't have two varieties here. They're always exactly like this. But that's nice. There's only 5 of them, but let's do another one. It's always the same way, but it's definitely different than the other stuff, isn't it? All right, let's try the next one. If you're good, I'll move on.
On the top?
Yeah, other questions, Victoria?
We need to put Ttest for the difference, or what is it that we have to use?
Oh, right up here, what their options were? I don't know. Victoria, tell me, what were their options there? T-test for the difference sounds exactly right. Is that one of their options? T-test for the difference. For two dependent. That's exactly it. T-test difference, two dependent. That's exactly it. These are dependent. They're not independent, right? They depend on one another. They're matched up. Same person, before and after, or alone in classroom. Yeah, that's a dependent sample, not an independent. They're connected, right? That's the same person, alone or classroom. Yeah, thanks. T-test difference, two dependent samples. See how they're connected? Is that making sense? Other questions on this one? All right, so number 2, complete an obstacle course. I don't know which, they're all the same. Probably just do one more. Memory test before and after a meal. Younger sibling, older sibling IQs. Running it, help. Okay, well, so let's see. What do we do? Want to do the, we'll do this one, I guess. All right, how about number 4? I'll just jump to number 4 here. Or was 3 more interesting? What was 3? Before a meal, after a meal? All right, we'll do that one, whatever. All right, so do number 3. Is memory ability before a meal worse than after a meal? 10 people were given memory tests before their meal and then again after their meal. The data is shown below. A higher score indicates a better memory ability. So would you recognize on the next exam that that's matched up data? Because this is the same person, huh? Before and after the meal. So that data is matched up. They're dependent upon one another. It's the same exact person. So let's go through the steps. You know the steps. Right, so 10.3, matched pairs. Step number 1, data into L1 and L2. Step 2, L1 minus L2 stored into L3. So you get it all in L3, the differences into L3. So let's do that. So I should have said here for step 2. Second quit. And then step 3, L1 minus L2 stored into L3. All right, so we got it in there, and then we go to the t-test. Do you see why we're not going to 2 sample? Because we don't care about the 2 samples anymore. We only care about the one L3 list. Right? That's holding the differences. So that's why we just do normal t-test now. T-test and the mu0. I don't even know what it is. I didn't write the claim again. So claim. What's being claimed here? Is memory ability before a meal worse than after a meal? Yeah, how are you doing on that? Is that part confusing? So what does it mean if before is worse than after? If you subtract them, you'll get negative again, huh? If the before is lower, you subtract them. So that means the difference will be less than 0. Will be negative. Does that make sense? That's negative. Less than 0 is negative. Greater than 0 is positive. Good, okay. So then HO, H1. HO is always equal to 0. H1 then will be less than 0. And you know the weak evidence, strong evidence stuff. And so then the mu0 is just going to be 0, isn't it? Because that always comes from the number next to H0. Every time without exception. And what else does it ask us for? Oh, we were supposed to choose data, of course. I skipped over that. U0 is 0, data, and the list is again L3 this time. Frequency is always 1, and we're doing a less than. Calculate. And I'm getting a t-value negative 2.711 and a p-value 0.0120, 1198, so it rounds up to 120, 119.8, so 120. And okay, so now we got to do the comparison. Question, is that p-value 0.0120? How does it compare to the significance level? What was the significance level? 0.01. That's a close one. Notice the p-value is a little bit bigger, isn't it? Just barely. P-value is barely bigger. So the p is not low enough anyway. P is not low. HO does not go away. We keep HO. Evidence is weak. Insignificant, insignificant. Get rid of the significant answers. So it's either the first or second. Yeah, can you tell already? Oh, insufficient. Yeah, there's weak evidence. Insufficient, right. There it is. Whereas they went back to significant. That's not right. And there we go. How are we doing? Is that making sense? Let's see, I'll go to younger sibling, older sibling. So is the younger sibling's IQ lower? Is that true on average? Younger siblings' IQs are lower? Why would this be matched data? Yeah, these two are related to each other, huh? So they're matched up. They're dependent. They're gonna rise or fall together, kinda, aren't they? Get the idea? We'd be able to recognize this on an exam as matched pair data. They're not like it's not like we just took 7 or 8 people that are young siblings and 7 or 8 just totally other people. These are matched up. They're all within one. Each pair's in the same family. They're related, huh? So matched pair data. All right. So let's write the claim. HO and H1. So what's the claim on this one? It's always about difference. Mu difference. And it's either going to be equal to 0, greater than 0, less than 0. So you want the younger ones to be lower. So you want this number lower than that number. So if you subtract them, what kind of, and this one's lower, when you subtract them, are you going to get negative or positive? Going to get negative, and negative is again less than 0. Same thing again, huh? Less than 0. That good? So then HO, H1, mu sub D equals 0, mu sub D less than 0. So you know what to do. Step 1, data into L1 and L2. And then second quit. Step 3, L1 minus L2 stored into L3. Let's do that. And then we go to Ttest. Ttest, and we hit data. And mu 0 is 0. List is L3. Frequency is 1, like always. And we're again doing less. All right, so this is mu D equals 0, mu D less than 0. Strong evidence, weak and strong. I'm getting a t-value, negative 2.407, and a p-value 0.0197. We getting that? And so then we say, is that p-value 0.0197, how does it compare to the significance level, which is 0.10? So how does that p-value compare? Much lower, huh? 0.01 is much lower than 10. So the p is low. So HO must go away. So cancel HO, keep H1, Evidence is strong. Significant evidence. Significant evidence. So significant, not these two. Which one of those two? Population, not the 10 younger people. You're always trying to draw a conclusion about all sibling IQ comparisons, not just these 10. The population of all siblings. Questions on that?